Hello everyone. We will now begin our lecture on section 3 of chapter 8, which is on perimeter and area. Now these are two types of measurements done on geometric shapes or geometric figures, and we will talk about what perimeter is versus what area is. We will learn formulas to calculate perimeters and areas, and then we will go into some application problems to measure perimeter and areas, right? Now these are the topics that we are going to cover in this section. First of all, we'll understand and use formulas for the area and perimeter of polygons. So we will look at different formulas for the different polygons, starting from a triangle to all the different quadrilateral figures, and how we use them to find area and perimeter. Then we'll talk about a very important and useful theorem called the Pythagorean theorem, which applies to triangles, and we will learn how to solve problems using the Pythagorean theorem. And then we will also talk about circles. So far we haven't studied circles yet, but we will go into that, understand and use formulas for the area and circumference of circles, and then we'll also go ahead and solve some application problems on conversion. All right. Now we'll first understand what the word perimeter means. The perimeter, represented by the letter P of a two-dimensional figure, is the sum of the length of the sides of the figure. So every figure is bounded, whether it's a four-sided figure or a three-sided figure or a seven-sided figure, it'll be bounded by lines on every side. All right. So the perimeter is the sum of all the sides, so the sum of the lengths of all the sides. That's what represents a perimeter. So when do we need to measure the perimeter of a figure? Let's say you have a rectangular lawn, all right, in your a rectangular yard, and you want to put up a fence around the yard. Then you will need to find the perimeter. All right, you don't put the fence inside your yard, you just put it around your yard. So in those cases you will need to know the perimeter of your yard so that you can buy the appropriate quantity of fencing to fence it. All right, so that's what is meant by perimeter. It is the sum of the lengths of the sides of a figure. The other term is the area. Area is represented by the letter A, capital A. It is the measure of the region within the boundaries of the figure. So this inside region, bounded by the sides, is called the area. So when do we need to measure the area? When you want to place sod in your yard, all right? You need to know how much sod you need to buy, because the sod will be spread all over within the bounded region of your yard. All right. So that's when you need to measure the area of something. Now this is a table giving you the formulas to calculate the perimeter and area of different figures. And as you will note, the perimeter is more of adding the sides of a figure, and area is more of multiplication. All right. So in the next slide, we will go over an explanation of how they came up with these formulas. All right. So let's go over the different formulas related to the different shapes we have here and see how they came up with the given formula. All right. So here's a figure of a triangle. This is a triangular figure, and each side is marked as S1, S2, and S3. These are all different sizes. S1 is the smallest size length, then S2, as we can make from this picture. All right. So again, remember, perimeter is the sum of the sides that form the figure. All right. So the sides that enclose the area, S1, S2, S3. So perimeter is S1 plus S2 plus S3. Now, the side on which the triangle is standing is referred to as the base and denoted by the letter B. So in this case, S3, the side S3 is also the base of this triangle. To find the area, we have to always look at the height of the figure. Now the S1 is not the height because it's a straight line, but it's not perpendicular to the base. The height always has to be perpendicular, meaning it has to be at right angles to the base or to one of its sides. So that's why we had to draw a separate line going straight up 90 degrees from the base to the peak of the triangle, to the top of the triangle, and we label that height. So in order to find the area of a triangle, we have to know the height of the triangle, and the formula is half multiplied by base, which is the length of the side, S3 in this case, multiplied by the height of the triangle. All right. Then we have the figure of a square. A square has equal measure of all sides, correct? If one side is S, then the other sides are all S. So when you measure the perimeter of a square, you're essentially adding the same value 4 times. So the perimeter of the square would be S plus S plus S plus S, which is 4 times S, correct? You're adding S 4 times, and that's why the perimeter formula is 4S. As far as the area is concerned, area is S squared. Area is S multiplied by the S on this side. So it's essentially length, all right, for any rectangular figure. The area is length times width. Now in the case of the square, the length and the width are all same measures. So that's why A will be equal to S times S, if that is the measure of the length. So S multiplied by S is S squared, correct? So that's why the formula for the area of a square is S squared. Next we go to the rectangle. The rectangle has only opposite sides of the same length. So if this side is L, the opposite side will also be L, the length. And if the width is W, then its opposite side will also have the same width, W. So when we perform the addition, it's L plus L, which gives us 2L, and W plus W is 2W. We add them all up together. It's like doing L plus W plus L plus W. You add up the two L's, you add up the two W's, and you add those quantities to get the perimeter. For the area, it's the length multiplied by the width. All right, length times width. That's the formula for the area of a rectangle, because the measure of the length and the width are different in a rectangle, unlike with the square. Now, parallelogram, again, because the lines are all slanting, we have to figure out the height in a parallelogram to calculate the area. As far as the perimeter is concerned, it's straightforward. It's 2b plus 2w. So again, uh, B represents one side, and in a parallelogram, the opposite sides are equal, just like with the rectangle. Only thing is the angles are not right angles in a parallelogram. All right. So if one side has a measure of B, the opposite side will also have a measure of B, and then the other two sides would have W. So it's twice B plus twice W, just in the case of the rectangle. And then the area would be B times H, so base times height. So measure of one side multiplied by the height taken from the base, from that particular side, the base, all the way up to the opposite corner, one of the opposite corners of the parallelogram. For trapezoid, again, this figure also we need to for this figure, we also need to measure the height. For the perimeter, it's S1 plus S2 plus B1 plus B2. Just sum up all the sides, the measure of all the sides. However, for the area, it's half H. So 1/2 times the height, and then within brackets B1 plus B2. All right, base the sum of the opposite sides from where the height was measured. Okay. Now let's work on some calculations based on measurement of perimeters, areas, and so on. The first example is on placing sod or grass on lacrosse field. So Rob wishes to replace the grass or sod on a lacrosse field. One pallet of Bethel Farm sod costs $360 and covers 480 square feet. If the area to be covered is a rectangle with a length of 360 feet and a width of 228 feet, determine the area to be covered with sod. So there are different parts to this question. The first part of the question asks what is the area to be covered with sod. So they give a lot of information here. One information is how much or the size of each pallet of sod, correct? One pallet of Bethel Farm sod costs $360 and covers $360 and covers 480 square feet. So that's the information on one pallet of sod. They've given us the area that one pallet can cover, which is 480 square feet, and they've also given us its cost. So the cost is $360 per pallet. And they've also given us information on the area that will need to be sodded. All right, so the first question is we need to find the area to be covered with sod. They've only given us the length of the sides, 360 and 228. So the area that we need or that needs to be sodded would be 360 multiplied by 228, whatever that calculates to. All right, so we're going to go to the next slide and see how they have done the solutions, but there are more parts to this question. So let's see what the other slide comes up with. So what we see here is that it was a rectangular area that we needed to find, correct? And the formula to find the area in a rectangle is length times multiplied by width. So if the length was 360 and the width was 228. When you multiply it, you get 82,080 square feet. So because each of these are feet, the units of 360, all right, the units for the length is feet, and the units for the width is also, it's also feet, right? So when you do the multiplication, you also multiply the feet. So feet multiplied by feet becomes feet squared. So it's square feet. So 82,080 square foot. All right, so that's how you write the units when you find the area. Area is always squared. So feet squared. Now the next part of the question asks, determine how many pallets of sod Rob needs to purchase. So we already calculated the area that needed to be covered. That was 82,080. And we were also given the size of each pallet. So each pallet had a size of, I think, 480, if I'm not mistaken. So maybe this was the size. The question is, how many pallets would be needed of this size? How many pallets of this size would be needed to cover an area of 82,080? So what we need to do is we have to take this value here, 82,080, and divide it by the size of the pallet. So the area that needs to be covered divided by the area of each pallet would give us how many pallets Rob would be needing. All right. So this is how they came up with the solution, same as what we just said. Area to be covered, which was the 82,080, divided by the area covered by one pallet, and that's 82,080 divided by 480 gives a value of 171. So 171 pallets, or each of size 480, would be needed to cover an area of 82,080. Now there's a third part to the question. It says determine the cost of the sod purchase. So how much will he need to spend to purchase the sod? So we were given the price of one pallet of sod, right? So the price of one pallet, price per pallet, was $360. $360. All right. And so if one pallet costs $360, how much would 171 pallets cost? All right. So we found from the previous part of the question that he needed 171 pallets to cover the area he wants to sod. So if each pallet costs 360, then 171 pallets would cost 360 multiplied by 171. So that's how they have worked it out here. The cost of 171 pallets of sod is 171 multiplied by 360, which comes to $61,560. So $61,560 is going to be the total cost of sodding a lacrosse field. Now we'll talk about a very important theorem that applies to right triangle. It's called Pythagorean theorem. All right. Now, before I go into the theorem, I just want to talk a little bit about the features and some terminologies that apply to right triangle. So I'm going to draw here a separate right triangle. Right. So let's say this is a right triangle, not a perfect figure. But in a right triangle, there's one angle which is a 90-degree angle, and that's what makes the triangle a right triangle. One of the angles is a right angle. Now, by convention, we denote the right angle with the letter C, all right, a capital C, and the other two angles are just referred to as A and B. So we have angles A, B, and C. C being the C being the right angle, where the right angle is. Now the side opposite the right angle is termed hypotenuse. All right, hypotenuse. That's a special term used to denote the side opposite the right triangle. Therefore, hypotenuse, that word is applied only for right triangles. All right. If somebody mentions hypotenuse, then you immediately know that the person is referring to a right triangle, and it is the side opposite the 90-degree angle. The other two sides are called the legs of the triangle. And we often denote the sides, all right, the sides with the letter, uh, that is a lowercase letter. All right, so the side opposite the angle will be denoted as C. All right, small c. The side opposite to angle A, here, the side opposite to angle A will be denoted by the lowercase a, the lowercase a. And the side opposite to angle B will be denoted by lowercase b. So that's how we represent the sides. It's just a convention, all right? It's a convention, so people know which side is opposite to which angle. Now, the Pythagorean theorem is credited to the Greek mathematician Pythagoras, and he came up with this, that the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. In other words, if you take the square of one of the legs and to it you add the squared measure of the other leg, then that will equal to the square of the hypotenuse. All right, so that is the formula. Leg squared plus leg squared equals the hypotenuse squared. And if we replace, instead of saying leg and leg, we don't know which leg it is, to be more precise, we can replace these values of the legs. We denote the legs by A and B. So we can write this or rewrite this as A squared plus B squared equals C squared. And that is the famous Pythagorean theorem, that the square that you build on side A plus the square that you build on side B will be equal to the square built on side C. All right, A squared plus B squared equals C squared. Symbolically, if A and B represent the lengths of the legs, A and B, right, we already marked them as A and B, all right, then, and C represents the length of the hypotenuse, the side opposite the right angle, then the Pythagorean theorem says A squared plus B squared will be equal to C squared. All right. Now let's look at an example where the Pythagorean theorem can be applied. All right, so I'm going to read through it first. It says the moat surrounding a castle is 18 feet wide and the wall by the moat of the castle is 24 feet high. See the figure. So we have a figure here which we will look at a little later. If an invading army wishes to use a ladder to cross the moat and reach the top of the wall, how long must the ladder be? All right, so let's look at the figure now. We see a picture of a castle, and this is a moat. Moat is essentially a ditch to protect the castle from enemies. So a moat is a ditch, or sometimes filled with water, all around that extend all around the castle. And the enemy here, in this case an army, would like to reach the top of the castle from one end of the moat, all right, from the further end of the moat, so to speak. All right, so let's see how this figure takes the shape of a triangle, a right triangle. All right, so we have the moat on the ground, and then the castle goes straight vertically up, and it makes a 90-degree angle with the moat. So the castle and the moat make a 90-degree angle. So this angle here is a 90-degree angle. Again, remember that we always represent the right angle with the letter C. So I'm going to mark it as C. All right. Now, the side opposite to the right angle is denoted by a small c, which is also called the hypotenuse. So this ladder here, whose length we need to find, will be really the hypotenuse of a right triangle formed by this figure. All right. Now, the other two sides can be named anything based on where we place the angle. So let's mark the lower end as A. So its opposite side will be represented by the small lowercase a. Let me erase it and write it properly here. So the side opposite angle A will be represented by the lowercase a, and if we have B for the other angle, uppercase B for the upper angle, then its opposite side will be represented by the small letter b. All right, so we see over here that the side opposite angle A is the height of the castle, 24 feet, and the side B, which is the length of the moat from the castle to its further end, is 18 feet. All right, so they represent A and B, the two legs of a right triangle. So if we know the values of the two legs, then recall that the Pythagorean theorem, this is what it looks like: a squared plus b squared equals c squared. That's the Pythagorean theorem, where a, b, and c are the lengths of the different sides. So if we know the length of side A, that would be 24 squared. Let's replace the value of A by 24. B is 18, so I'm going to replace B by 18 and square it, 18 squared. So if we know the values of A and B, we can find C squared by completing this calculation. So we'll see that in the next slide. All right. So here, let's look at the solution again. They set up the problem as a Pythagorean theorem. So c squared equals a squared plus b squared. That's the Pythagorean theorem. So 18 squared is the length of the moat. All right. Now, the only thing is, we, in our diagram in the previous slide, we represented 24 as A and B with 18, but it doesn't matter. All right, in the final calculation we'll get the same answer whether we have denoted the moat, length of the moat, as A or B. It doesn't matter. All right, so let's continue. C squared equals, they replace the value of A with 18 and the value of B with 24, and then they square it. So c squared equals 18 squared is 324, 24 squared is 576. Add them up and you get c squared equals 900. However, we don't want to know what c squared is. We want to know what c is, correct? What this side is. We don't want to know what c squared is. So in order to uh, take out the squared, we take the square root of both sides. So if c squared is 900, then if you take the square root of both sides, then you'll end up with c equals 900. The square root of 900 is 30. So the ladder needs to be at least 30 feet long in order for a person to go up uh, go all the way up to the top of the castle. We'll now talk about a different geometric figure called circles. So let's go through the property of circles. A circle is a set of points equidistant from a fixed point called the center. So over here we have a picture of a circle, and we have a center point in the middle of at the center of the circle. We have a point here, and the circle is formed uh, by uh, by creating points all around the center point, which is equally distant. Equidistant means the distance from the center point to a particular point is the same all around. All right, so that's what makes a circle a circle. All right, now this boundary line along which all the points that are equidistant to the center lie is called the circumference. It's like the boundary line, so to speak. All right, just like for polygons we have perimeters, for circles we have circumference, and that is has a curved shape. It is a round shaped. All right, now a radius r of a circle is a line segment from the center of the circle to any point on the circle. All right, so if we draw lines from the center point to any point on this circumference on the boundary, then we will uh, that particular line is called a radius. All right, so here we have the radius denoted as r, but the radius can be anywhere from the center to the circumference. All right, this is the radius, this is the radius. If you draw another line from the center to the circumference, this is the radius, and the length of the radius will always be the same for any circle. That defines the property of the circle. And the line uh, that runs from one end of the circle to the other end of the circle, passing through the center point, is called the diameter. All right, it's called the diameter. And let's bring up the definition of it. It says a diameter d of a circle is a line segment through the center of the circle with both end points on the circle. So it basically connects the opposite ends of the circle and passes through the center point. And it's the diameter, and the diameter is the double of the length of r. All right, because you have two center points, two lines. Think of the diameter as two r's. So this is an r from here, from the center point to the left side, left end of the circle, and then the other radius is from the center to the right end of the circumference. All right, so the diameter is 2r or twice r. Okay, now let's talk a little more about the circumference of a circle. The circumference of a circle corresponds to the perimeter of a polygonal figure. All right, so it is kind of the boundary line, but it's not a line, it's a curved shaped figure. That's what the circumference is, but it forms the boundary around a circle. And the circumference can be measured. It could be, if we could extend it out and measure it, we could call it the length of the circumference. And there's a formula to calculate the circumference, and here it is. The C is equal to 2 times pi times r. R is the radius and the pi is a constant value. All right, so pi has the value of 3.14159 and it's a non-terminating decimal value. All right, and essentially what pi is, uh, it's a value obtained by taking the ratio. All right, it's essentially the ratio of the circumference and the diameter of a circle. Circumference and diameter. It's the ratio between the circumference and the diameter of a circle, and it was found that by early mathematicians, when they measured this or took the ratio of the circumference and the diameter of any circle, whether it be this big or this big or even this big, if you took the if you measured the circumference and measured the radius and took their ratio, you would always get a value which is 3.14159, and that's represented by the Greek letter pi. All right, so and pi is used extensively in measurements of circles and also in other areas of mathematics. But circumference is equal to 2 times pi, which is this constant value, times the measure of the radius. Now, another measurement that is taken on circles is to find the area, that is the bounded region inside the circumference, and that is area represented by A is pi, the constant value pi, multiplied by r squared. Pi r squared is the area of a circle. All right. Now let's look at an example problem dealing with areas of circles and parallelograms. So in this figure, we see that there's a circle etched inside a parallelogram, right? This figure here, the blue colored figure is the parallelogram and the white is a circle. So the question says determine the shaded area, use the pi key on your calculator and round your answer to the nearest hundredth. All right, so we have to find the area, the blue area, all right, the blue region in this figure. So we know that we have the parallelogram here. This blue is the parallelogram, and within it is a circle, a circular plate, and the base or the length of this side of the or the bottom of the uh, parallelogram is 10 feet, and the radius of the circle inside it is 2 feet. So if we can find the area of the parallelogram, and from it, if we subtract this white portion, which is the circle with radius 2 feet, we should be able to find the area of this blue shaded region. All right, so let's see how we can go about it. Now, to find the area of a parallelogram, we have to use the formula, which is B times H. B is for the base multiplied by the height. So we know that the base has a value of 10 feet. How do we find the height? Height is the distance, the perpendicular distance from the base to the opposite side. All right. So if we draw a line from the base here, let's use a different color, from the base, but it should be a perpendicular line. All right, perpendicular meaning that it is right angle to the base. So if we extend the line all the way up to the opposite side, then that's also the diameter of the circle. All right, and the diameter is 2 times the radius, correct? So that's what our height will be. Because the radius of the circle is 2 feet, then the diameter is twice the radius. So 2 times 2, 4 feet. So that's how they came up with the value for the diameter of a circle. So at this point, we will find the area of the parallelogram and then the area of the circle. And then in the next step, we will be subtracting the area of the circle from that of the parallelogram. All right. So let's pull up here. The area of the parallelogram is base times height, and we said that the height is really the diameter of this circle, because the diameter runs perpendicular or at right angles from the base all the way to the top of the parallelogram. All right, so base is 10, height is 4. How did we get the 4? The diameter is 2 times the radius, and they've given us the radius as 2 feet. So 2 times 2 is a 4. So we get 40 square feet for the area of the parallelogram. Next is the area of the circle. So the formula for that is pi r squared. So pi, you substitute the value 2 for r. So 2 squared is 4. So it's 4 times pi, right? 4 times pi. So it comes to 12.57 square feet. And then, of course, you have to subtract the 2, which we do in the next slide. So here's the final step to the solution. We already found the area of the parallelogram using the formula b times h. We also found the area of the circle using the formula pi r squared. So now we have to subtract the 2. All right. So area of the shaded region, this blue region, would be 40, which is the area of the entire parallelogram. And then the area of the circle was 12.57. So when we do the subtraction, we get a value of 27.43 square feet. All right. So this is the final solution, and this is how we will go about solving problems on areas of different geometric figures or geometric shapes.